Yes, sir.
So basically, this experiment was done to understand the structure of the atom, how the atom is. Before that, Thomson was the person who has done a rough idea about it. He presumed that there is a solid atom, is an entire solid, and then the electrons and the positive charge are just placed uniformly around it. But that Rutherford found that no, it is not true. There is a nucleus at the center of the atoms, which is positive, and electrons are evolving. That is what we know as of now. So how he was able to achieve that? What he has done, he has taken a alpha particle and projected towards a say gold foil, any metal foil he can do. He has chosen the gold, and then he has projected the alpha particle towards the gold foil. And then he had seen what is happening. He has seen that most of the alpha particles are passed undeviated, right? A very few has scattered, making some angle with the original path, and then very few, it was more than 90-degree scattering angle, and then still out of that very few, that is 1 in 20,000 alpha particle, he found that it is going to retrace back the same path. Suppose it is going left to right, so after the interaction with the gold foil, it has come back to the same path, right? Alpha particle, any idea what is that alpha particle? This is your positively charged particle, correct? It is your positively charged particle. You must be knowing that.
Yes, sir.
Okay. So positively charged particle, if it is projected towards the gold foil, we have seen that very few are very few, as we discussed, is going to be retraced back its own path, right? So at the center of somewhere, it is just even less than point in size, but yeah, somewhere we are having the positive charge. That is what he understood. Because the alpha particle, which is being projected from a certain distance, right? Projected means it will have some kinetic energy, right? And then these alpha particles, once it is projected towards the we can say gold foil region can be, I just take it like gold foil is region is say up to that. Then he found that most of the alpha particle which is being projected, they are passing undeviated, correct? They are passing undeviated, means it will just go passing like that. The few of them are having just a few lines only we had taken, maybe millions in that. So few of them had a deviation scattered in this way, correct? And very few of them as a scattered more than 90-degree, and out of that, a very few, they have he has found that is going to retrace back its own, right? It is stopping somewhere and then stopping somewhere and then going back. So that is what he has observed by experiment. Now he has concluded based off these experiments. The most of the alpha particle is going undeviated, means he understood that it is there is an empty space also in the atoms, right? It is unaffected by, there is no deviation in that, unaffected, and they kept on going in the same directions, correct? And then a few of them had a deviation, means it was going in this path, now it will have, this is the scattering angle we'll call, right? It was going on this side, now it is, so this will be theta. Now theta, this angle is 1 in 20,000 alpha particles. He observed that the theta is greater than 90 degree. right? Theta is greater than 90 degree. What is theta? Theta is the angle of scattering, right? What is theta here? Theta is the angle of scattering. Angle of scattering is angle through which the alpha particle deviate from the original path, right? So the angle of, if I try to understand angle of scattering, we'll say that the angle through which alpha particle will deviate from its original path, right? So he has taken, Rutherford has taken that gold foil for his experiment, right? And then alpha particle is projected, positively charged particle, which is projected towards the gold foil, right? Projected towards the gold foil. So, well, he has understood that there is a lot of empty space, as we have discussed. And then from where it is just making a U-turn, the alpha particle is making U-turn, this has to be positive because alpha particle is positive, and only the positive charge can repel it in the same directions, right? An effect of positive charge, if it is near that another alpha particle parallel to that, very close to that line where it is making U-turn, they will have the scattering angle because of the effect of that positive charge. So he understood, okay, there is some positive charge uh, at the center of that atoms. That is what he understood, right? And that positive charge where at the center is known as the nucleus, right? So we can write that also here. Uh, can you note it down up to that?
Yes, sir, I have noted it.
Okay. So taking that into account now, if you try to write further here, the points I'll be writing here. Few alpha particles deviates by an angle greater than 90 degree. Out of which very few makes U-turn and come back after momentarily stopping. Stop near the foil, very near to foil. So this is the understanding, and that has concluded that there is a positive charge. There is positive charge. Just a minute. Positive charge concentrated at the center of atom, which is known as nucleus. Okay.